Hi everyone, my name is Thomas Kim. Today is 6th of August 2022. This is my 37th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL DBB. In this episode, I will discuss curiously recurring template pattern. I will create 3 videos about C, R, T, P programming pattern. More specifically, I will discuss deducing this. Please double-click this link. In this document, if you scroll down, you can find CRTP. Please double-click this link. In my current episode, I will discuss this part of code. In my next episode, I will discuss this part of code. Please understand that this is not complete C++ program and it doesn't work if you try it by yourself. If you want to follow my current and future sessions, I assume you have watched my previous videos listed here. From episode 36, please double-click this link. I assume you have watched my previous videos listed here in sequential order. Otherwise, you may not be able to follow my current and future sessions. From episode 36, please double-click this link to download the source code from our previous episode. Show in folder. Unzip it. Rename the folder 37 CRTP. Copy the folder path. Copy. Paste it in your working directory. Now open up Visual Studio Code. Open CPP 17 2023 parallel, your working directory. Select folder 37. Click this button crtp.cpp. Hit enter. Ctrl V. Include cpg, std, extensions. Curiously recurring template pattern or CRTP is a very powerful C++ programming pattern. We can use it for dynamic polymorphism as well as static polymorphism. In this episode, I will discuss CRTP for static polymorphism. Class some type. Don't miss semicolon. Protected int m value public. We create constructor int value. We provide default value m value. This is constructor. Now int l value reference operator plus plus. This is unary prefix increment operator. Here this m value. increment, then return this m value. print SED OStream operator SED OStream OS some type constant L value reference S OS S return OS. Now we will test this function. Before we test, I will add one more function, int constant int L value reference get constant no except return this m value. Now for the test some type int main, copy this, paste it here. Now some type S5 std cout s std and there. Before increment plus s after increment this is unary prefix operator. Now open up your command prompt for Microsoft compiler cd 37 crtp 037 clehsc sdd c++23 latest crtp.cpp fe m.exe hit enter. clsm something wrong. Sorry, I made a simple mistake. This function is recursive. We are taking two arguments. The first is OS, this OS. The second is S, an object of type sum. An object of type sum. It is recursive. Please be careful. M value. Now we rebuild clsm. It works perfectly. Now we will add unary postfix increment operator. Please understand that I removed L-value reference here to overload to operator function. We need tag. This tag is used to define postfix increment operator int. Now here old value, we copy old value, then we increment this m value, or we can say this operator plus plus. This is equivalent. We are calling this function from here. Then we return old value. Now scroll down. S++ unary postfix operator int. Then after post increment, we build again. CLSM. It works perfectly. Now scroll up. We will disable this part. Instead, here public, or it can be private or protected. You can use either private or protected. Postfix increment. We pass some type as a template argument. Now here template type name self type struct postfix increment. Don't miss semicolon. Here auto operator plus plus int. This is postfix increment operator. We use self type. This is L value reference. Self static cast self type L value reference. Then this is pointer. We need to dereference like this. Int value self has member get. We are calling this member to retrieve m value. Or we can say self m value. We can also do this. Now we call this function like this, plus plus self. This is identical to self operator plus plus. Then return value, or I would say old value. So we defined postfix increment. This does not work. Even if it is public, it does not work. Now here we are using unary postfix operator, but we delete it. Instead, we use base class postIncrement by passing this sum type here. So this postfix increment, this template class has a member postfix increment plus plus operator. We are calling this operator. This operator, we do typecast. This self type is sum type. So this self is sum type, an instance of sum type. This self is an instance of sum type. We are calling prefix increment this function here, but it does not work. We are calling postfix operator, but it does not work. We rebuild 75. Sum type does not define this operator. We need to declare in the public section using postfix increment operator. We have to explicitly declare using declaration for operator function. We are instructing C++ compiler that we will be using this member function. This is the correct way. So this code does not work. It does not help using declaration here. This declaration is very important. Now we build again. We cannot access this member. but we have get in public section, so instead of this self get, now we build CLSM. It now works perfectly. Now I copy this, copy, paste, postfix, decrement. This is decrement. This is decrement. Now scroll down. We define decrement. This is decrement. Now here, copy, paste. This is postfix decrement. So copy this, paste it here using postfix decrement operator minus. Now scroll down. We need to test minus minus s after post decrement. Prefix decrement. Copy, paste, after postfix decrement. All these things should work. Now we rebuild CLSM. This is initial value. We incremented. Then we postfix incremented. Prefix decremented. Postfix decremented. Everything works. Please understand that we defined prefix, increment, and decrement by using postfix increment, postfix decrement, and some inheritance. With this, using declaration, we created a perfect class.